Hi and welcome. The question is, how many terms in this geometric series does it take in order to come up with a grand total, a sum of 42 3/4, 42 3/4. So how many terms are there? So what are we looking for? We're looking for n, the number of terms to achieve a grand total of 42 3/4. So how we're going to do this? Well, let's get resourceful and recognize and identify what data we have to begin with. So let's start identifying what we have. So the clues are in the questions. So what do we have? Well, we have A, the first term is given to us. So let's write that down. So A equals 64. Now, if we look at each term, we can come up with the common ratio. Now, many of you already know that the common ratio is what? The common ratio is a constant number that you multiply each term. You keep multiplying by that constant number in order to find and form successive terms. And it's R, the common ratio, equals the second term divided by the first, which is equals the third term divided by the second term. So R here in this particular instance would be R equals negative 32 all over 64, which is equivalent to 16 positive all over negative 32. And if you formulate that, R will equal negative 1/2. So there's our common ratio. There's our first term. Now, what else do we have? Well, we know, given over here, that the sum to n, the sum of all the terms must equal 42 3/4. So Sn equals 42 3/4. So that's all the information that we have, that we're given. So what are we after? What's our outcome? Our outcome is to find n. That's the missing link. Now, in order for us to find this, we need to use the formula down here, sum to n terms. Now, sum to n equals A, the first term, and we have here 1 minus R, the common ratio to the power of n, all over on the denominator, 1 minus R, the common ratio. Now, that's a good formula to use when R is less than 1, and it's a fraction actually, and it's a negative fraction. So that's a good formula to use here. So let me just write that formula up again over here. So sum to n, actually let's write it over here right underneath here. So we'll go sum to n equals A. We have 1 minus R to the n all over 1 minus R. There we go, there's our formula, just like it is here. So all we have to do now is start putting in the values that we have into it in order to find what we can't find, which is this n. That's what we're looking for. So let's start putting the values in. There's our first value, 42 3/4. Let's put that in there. So we'll go 42 3/4 is equal to A, the first term. What's A? A is 64. Let's put that in here. 1 minus R. What's R? It's negative 1/2. Negative 1/2 to the power of n, close bracket, all over 1 minus negative 1/2. That's going to be two negatives there. They're going to turn into a positive. So that's eventually going to look like this. 42 3/4 equals, just writing it out again, 64. 1 minus negative 1/2 power n all over 1 plus 1/2 is 1.5, which is 3 on 2, isn't it? So we have 3 on 2. So let's multiply both sides by 3 on 2. So multiply by 3 on 2, multiply by 3 on 2. Both sides, let's multiply. So that's going to give us a grand total on this side. We're going to get, okay, we're going to get 513. That works out to 513 all over 8. And that's going to equal, that's going to cancel down the bottom there. It's just going to equal what we have before, 64, bracket 1 minus negative 1/2 to the power of n. Okay, what can we do with that? Okay, there's an opportunity here for us to divide both sides by 64. Let's get rid of that 64 right over there. So we'll divide both sides by 64. So divide by 64 and divide by 64. So that'll cancel that there. So that'll give us up here on this side 513 over 512, which equals 1 minus negative 1/2 to the power of n. That's what we're after. Okay, what can we do to further simplify this? Well, what we can do is subtract 1 from both sides. I'm going to subtract the 1 over here. Actually, I'm going to multiply throughout. Let's multiply throughout by negative 1. That'll kind of help us equate it. So I'm going to multiply by negative 1. Multiply throughout everything by negative 1. That's going to yield a value. Let me just put. That's going to yield a value here of negative 513. Negative 513 all over 512. And that's going to equal negative 1. Negative 1. The sign there changes from positive 1 to negative 1. And that's negative 1/2, so it becomes plus. Plus negative 1/2 to the power of n. You might notice that everything's changed. That's now a negative. There it is, a negative. That plus 1 becomes a negative, and that minus there becomes a plus. There's the plus there. So I've just changed the sign, and maybe you're wondering, why did we do that? Well, now it's easy to take this guy and bring it over there. So let's add 1 to both sides. Plus 1. Plus 1 to both sides. So that means we're going to have here 1 minus 513 on 512, which equals negative 1/2 to the power of n. I'm going to put n as red because that's what we're after. So let me just do that. Just put a little boundary there. So there's our n we're after. Now in the calculator, 1 minus 513 divided by 512 ends up becoming a grand total of 1 over 512. Okay, so that's 1 minus that 512. Just checking. Okay, so that's going to be a negative. Okay, that's a negative 512, and that equals an equivalent of negative 1/2 to the power of n. We're after that n, aren't we? So we can look at that 1 on 512 and do a guess and check. Now you could do logs. That'll take a bit long, but guessing and checking, what would that be? What would it be? It would be 2 to the power of something will give us that, or 1/2 to the power of something will give us 1 over 512. Now they're both negatives, so we can cancel them out. So make that positive, make that positive. So what can that be? Well, 1 over 2 to the power of something is going to give me 1 over 2 to the power of n. So that's something, what could it be? We want to get 512. So that's clearly going to be 2 to the power of what? On your calculator, 2 to the power of 7 doesn't work, 2 to the power of 8 doesn't work, but 2 to the power of 9 works. 2 to the power of 9 is 1 on 512. So therefore, because the bases are the same, we can safely say that n equals, and this is the number of terms. How many terms do we need in order to reach a grand total, a sum of 42 3/4? So the number of terms required is right here, which is n equals 9 terms are required for that grand total.